Hello, this is Python and Deep Learning Module 2 ICP-7. In this ICP-7, we need to do the test classification using NLTK, and then here we have to use two classifiers, SVM and KNN, and do the test classification and see how accuracy changes, and print the classification report of both the classifiers, and change the parameter of TF-IDF vectorizer to bigram of range 1 2, and again check for the accuracy of the classifier. And then next we need to set TF-IDF vectorizer argument stop words to English and check the accuracy of the classifier. So coming to the program, here I have imported the required libraries, imported the data, and I have divided the 20 news groups data into testing and training data. And then here, as you can see, I have used KNN classifier to classify the data and checked for the accuracy of KNN and printed the classification report. And then next, I have created an SVM classifier to classify the data and check the accuracy score, and then printed the classification report. And after that, we need to set TF-IDF vectorizer parameter to use bigram. As you can see here, I have used bigram and set the range 1 2, and then I have used SVM classifier and bigram together and check the accuracy of the classifier. And then next, we need to change the TF-IDF vectorizer argument stop words to English and check the accuracy, and here I have printed the accuracy score. As you can see below, for KNN the accuracy is 0.659, and here is the classification report, and for the SVM the accuracy is 0.834. so we can see there is a big difference, great difference between these two classifiers accuracy, and SVM works well with the 20 news groups data for classification. And then I have used SVM with the bigram and SVM with the stop words. As you can see, the classifier slightly increases from previous accuracy score on just using SVM classification. And then coming to the next question, we need to extract information from Wikipedia natural language processing page and then save the results into input.txt file and use that input.txt file to do tokenization, parts of speech, stemming, lemmatization, trigram, named entity recognition, and plot the frequencies of the words. As you can see, I have imported all the required libraries, imported NLTK and all the required libraries from NLTK, and then imported beautiful soap to get in the dataset from the URL, as you can see here, and I have printed the data from the URL, and then I have printed some of the stats of the data. As you can see, number of sentences. As you can see here, I have installed TextStat and printed some of the statistics of the data. So here we can see number of sentences are 850 and number of characters and number of words in it. And here I have checked for number of parameters, number of paragraphs in the data. There are 2307 paragraphs in the data. So here I have opened the input.txt file. As you can see here, input.txt file. So here is the input.txt file. So as we go below, over here I have opened the input.txt file, and then I have used word underscore tokenize function for the word tokenization and sentence underscore tokenize function for sentence tokenization, and I have printed the word tokenization over here, and then I have used sentence sent underscore tokenize function of NLTK to print the sentence tokenization over here. As you can see here, for the word tokenization, here is the output. For the and then sentence tokenization, here is the output. As you can see here, everything is divided into sentences, and then the word tokenization divided into a list of words over here. And then here I have used paused underscore tag to get the parts of speech in the data. And then for the lemmatization, I have used WordNet lemmatizer and printed the data. As you can see here, I have used Foster stemmer for stemming and Lancaster stemming and Snowball stemmer functions for stemming, and have printed the values over here. And then for trigram, I have imported trigrams from NLTK and then printed the values over here. As you can see, we have the output over here. And then for the named entity recognition, I have used these functions and then printed the data. And then to plot the frequency of the words in the data, as you can see, I have printed each word and the frequencies over here. As you can see here, the Google has more frequency. The word Google has more frequency in the input.txt file. And then I have printed the most common things in the word tokenization function from the word tokenization variable, and I have printed all the values. And I have printed all the words used word tokenization, and I have printed all, just the words present in it, and I stored just the words in the variable words, and I printed the words. So this eliminates all the numerical values present in the data, so only we have words from the data. And then I have used the words variable over here, and I've used frequency distribution of the words, keeping the 20 most common tokens. As you can see here, these are the most frequently. These are the words which has more frequency in the data, that is input.txt file, which we are getting from the Wikipedia natural language processing page. This is the end of the project. Thank you.